National Electrical Code Section 300.7 B prohibits installing conduits or raceways in air ducts or plenums. National Electrical Code Section 300.22 C1 requires conduits to be installed in a raceway outside of conditioned spaces unless specifically allowed. The unit manufacturer's specifications should be followed to ensure the unit's warranty remains valid. If the manufacturer prohibits wiring inside the unit, it should not be installed that way. Conduit and wiring within the conditioned space could overheat due to the elevated temperatures and create a fire hazard. Moisture can condense on the conduit and wiring, leading to short circuits or equipment damage. The presence of conduit and wiring within the unit's supply air path can impede airflow and reduce the unit's efficiency. It is recommended that you install conduit and wiring outside the conditioned space, as per code and manufacturer's guidelines. Use flexible conduit such as tight flexible metallic conduit to minimize the risk of damage from movement. Seal all points of entry into the unit to prevent air leakage and potential moisture problems. It is strongly recommended to follow the manufacturer's guidelines and code requirements by installing conduit and wiring outside the conditioned space of the rooftop air conditioning unit. This will ensure the safety, reliability, and efficiency of the unit. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. The NEC provides specific guidelines for conduit and wiring installations to minimize hazards and ensure proper functionality. Article 300 covers general wiring methods and requirements for all wiring installations. This article is very crucial because it sets the stage for safe and compliant electrical systems. Section 300.7 addresses raceways exposed to different temperatures. This section is critical when dealing with rooftop air conditioning units because the conduit might transition between indoor and outdoor environments, or between conditioned and unconditioned spaces. Subsection B specifically prohibits installing conduits or raceways in ducts used to transport dust, loose stock, or flammable vapors. More importantly for our discussion is the prohibition of installing conduits or raceways in environmental air ducts or plenums. Plenums are spaces used for the conveyance of environmental air. Running conduits in these spaces can introduce fire hazards and compromise air quality. Section 300.22 delves deeper into wiring in ducts, plenums, and other environmental air handling spaces. This section provides detailed requirements for electrical installations in these areas to prevent fire and smoke propagation. Subsection C1 specifies requirements for wiring methods for other spaces used for environmental air. These spaces are typically above suspended ceilings or under raised floors used for environmental air handling. This subsection generally requires that wiring be enclosed in raceways. It stipulates that wiring methods must be installed in a raceway. This helps contain potential fires and prevents the spread of smoke. Exceptions to this rule exist, but they are very specific and must be carefully evaluated. Understanding and adhering to these NEC sections is essential for ensuring the safe and compliant installation of conduit and wiring for rooftop air conditioning units. Ignoring these codes can lead to safety hazards, code violations, and potential equipment malfunctions. The manufacturer's guidelines for installing a rooftop air conditioning unit are crucial for maintaining the unit's warranty and ensuring its long-term performance. These guidelines often specify approved wiring methods, conduit types, and installation locations. Deviating from these guidelines can void the warranty and potentially damage the unit. Rooftop air conditioning units are complex systems with specific operating parameters. Improper wiring or conduit installation can disrupt airflow, cause electrical problems, and reduce the unit's efficiency. The manufacturer's instructions are designed to optimize the unit's performance and prevent such issues. Always consult the manufacturer's installation manual before commencing any work on the air conditioning unit. This manual typically provides detailed diagrams, specifications, and step-by-step instructions for proper installation. Pay close attention to the sections related to electrical connections, wiring methods, and conduit routing. These sections often include specific warnings and precautions to prevent damage or injury. If the manufacturer prohibits running conduit inside the air conditioning unit, strictly adhere to this requirement. This prohibition is usually based on concerns about airflow obstruction, condensation buildup, or potential electrical hazards. Attempting to bypass this restriction can lead to serious problems and void the warranty. Contact the manufacturer's technical support team if there are any uncertainties about the installation process. They can provide clarification on specific requirements and offer guidance on best practices. Following the manufacturer's guidelines is not just about maintaining the warranty, it is also about ensuring the safety, reliability, and efficiency of the air conditioning unit. By adhering to these guidelines, you can avoid costly repairs, extend a unit's lifespan, and ensure optimal performance. Installing conduit and wiring inside the conditioned space of a rooftop air conditioning unit can introduce several potential hazards. Firstly, elevated temperatures within the conditioned space can cause the conduit and wiring to overheat. Overheating can degrade the insulation on the wires, leading to short circuits, ground faults, and potentially fires. Secondly, moisture condensation can occur on the conduit and wiring, especially if there are temperature differences between the inside and outside of the unit. Condensation can corrode the metal components and create conductive paths, increasing the risk of electrical failures. Thirdly, running conduit and wiring inside the unit can obstruct airflow, reducing the unit's efficiency. Restricted airflow can cause the unit to work harder, consume more energy, and potentially overheat. In the event of a fire, the presence of conduit and wiring within the conditioned space can accelerate the spread of flames and smoke. This can endanger occupants and cause significant property damage. Improperly installed conduit and wiring can also create tripping hazards and electrical shock risks for maintenance personnel. For example, exposed wires or sharp edges on the conduit can cause injuries. To mitigate these hazards, it is crucial to install conduit and wiring outside the conditioned space, following the manufacturer's guidelines and applicable electrical codes. Use appropriate sealing methods to prevent air leakage and moisture intrusion. Regularly inspect the installation for any signs of damage or deterioration, and promptly address any issues to maintain safety and reliability. By understanding and addressing these potential hazards, you can ensure the safe and efficient operation of the rooftop air conditioning unit. The installation of conduit and wiring for rooftop air conditioning units should adhere to recommended practices to ensure safety, reliability, and efficiency. Firstly, install conduit and wiring outside the conditioned space of the unit. This minimizes the risk of overheating, condensation, and airflow obstruction. Route the conduit along the exterior of the building, following the shortest and most direct path to the unit. Secure the conduit properly to prevent movement or damage from wind, vibration, or other environmental factors. Secondly, use flexible conduit, such as type flexible metallic conduit, to minimize the risk of damage from movement. Flexible conduit allows for some flexibility and movement without putting stress on the wiring connections. This is particularly important for rooftop installations where the unit may be subject to vibration and thermal expansion. Choose a flexible conduit type that is suitable for outdoor use and resistant to moisture, sunlight, and temperature extremes. Thirdly, seal all points of entry into the unit to prevent air leakage and potential moisture problems. Use appropriate sealing compounds or gaskets to create a tight seal around the conduit fittings and other openings. Air leakage can reduce the unit's efficiency and increase energy consumption, while moisture intrusion can lead to corrosion and electrical failures. Follow the manufacturer's recommendations for sealing materials and methods. Regularly inspect the installation for any signs of damage or deterioration, and promptly address any issues. Check for loose connections, cracked seals, or corroded component. Replace any damaged parts immediately to maintain the integrity of the installation. By following these recommended practices, you can ensure the safe, reliable, and efficient operation of the rooftop air conditioning unit. Proper installation is essential for preventing costly repairs, extending the unit's lifespan, and maintaining a comfortable indoor environment. In conclusion, adhering to both the manufacturer's guidelines and relevant electrical codes is paramount when installing conduit and wiring for rooftop air conditioning unit. Prioritizing these guidelines ensures the safety, reliability, and efficiency of the unit's operation. Ignoring these established protocols can lead to a cascade of problems ranging from compromised performance to potential safety hazards. By diligently following the manufacturer's instructions, installers can prevent issues such as airflow obstruction, which can significantly reduce the unit's cooling capacity and increase energy consumption. Proper installation also minimizes the risk of condensation buildup, which can cause corrosion and electrical failures. Compliance with electrical codes, such as the National Electrical Code, is equally crucial for ensuring safety. These codes provide specific requirements for wiring methods, grounding, and overcurrent protection to prevent electrical shocks, fires, and other hazards. Installing conduit and wiring outside the conditioned space of the unit, as recommended by both manufacturers and code, is a key best practice. This minimizes the risk of overheating, insulation degradation, and the spread of flames in the event of a fire. Using flexible conduit to accommodate movement and vibration, and sealing all entry points to prevent air leakage and moisture intrusion, further enhances the reliability and efficiency of the installation. Regular inspections and maintenance are also essential for identifying and addressing any issues before they escalate. Checking for loose connections, damaged wiring, or corroded components allows for timely repairs and prevents costly downtime. By embracing these best practices and prioritizing compliance with manufacturers' guidelines and electrical codes, you can ensure the long-term safety, reliability, and efficiency of rooftop air conditioning units. This not only protects the investment in the equipment, but also provides a comfortable and safe indoor environment for building occupants. Always consult with qualified professionals and stay informed about the latest codes and standards to ensure the highest level of safety and performance. Maintaining a safe and efficient electrical system requires a comprehensive understanding of various concepts and best practices. Firstly, grounding is a critical aspect of electrical safety. Grounding provides a low-resistance path for fault currents to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. Properly grounded systems ensure that metal enclosures and equipment are at a safe potential, minimizing the risk of electrocution. Secondly, overcurrent protection devices, such as circuit breakers and fuses, are essential for preventing damage to electrical equipment and wiring. These devices are designed to interrupt the flow of current when it exceeds a safe level, protecting against overloads, short circuits, and ground faults. Selecting the appropriate overcurrent protection device for each circuit is crucial for ensuring reliable protection. Thirdly, proper wire sizing is critical for preventing overheating and voltage drop. The size of the wire must be adequate to carry the expected current without exceeding its ampacity rating. Undersized wires can overheat, leading to insulation damage, fire hazards, and reduced equipment performance. Voltage drop occurs when the voltage at the load is significantly lower than the source voltage, resulting in reduced efficiency and performance. Fourthly, conduit and raceway systems provide physical protection for electrical wiring, shielding it from damage and environmental factors. Conduits also help contain fires and prevent the spread of smoke. Selecting the appropriate type of conduit for the application is important, considering factors such as location, exposure to moisture, and mechanical stress. Fifthly, regular inspections and maintenance are essential for identifying and addressing potential problems before they lead to failures or safety hazards. Inspection should include checking for loose connections, damaged wiring, corroded components, and proper operation of overcurrent protection devices. Maintenance activities may include tightening connections, replacing damaged wiring, and testing grounding systems. Finally, documentation and labeling are important for ensuring that electrical systems are properly understood and maintained. Accurate wiring diagrams, circuit directories, and equipment labels help technicians quickly identify and troubleshoot problems. Proper documentation also facilitates future modifications and upgrades to the electrical system. By understanding and implementing these concepts and best practices, you can create and maintain a safe, reliable, and efficient electrical system that meets the needs of your facility. Electrical safety is a paramount concern in any building or facility, and it is crucial to implement comprehensive measures to protect people and property. Firstly, training and awareness are essential for ensuring that all personnel who work with or around electrical equipment are properly trained and aware of potential hazards. Training programs should cover topics such as electrical safety procedures, lockout/tag-up procedures, and the proper use of personal protective equipment. Regular safety meetings and awareness campaigns can help reinforce safe work practices and promote a culture of safety. Secondly, personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc flash suits should be used whenever working with or near energized electrical equipment. PPE provides a barrier between the worker and potential electrical hazards, reducing the risk of shock, burns, and other injuries. Selecting the appropriate PPE for the task is crucial for ensuring adequate protection. Thirdly, lockout/tag-up procedures are essential for preventing accidental energization of electrical equipment during maintenance or repair work. These procedures involve disconnecting the equipment from its power source and securing the disconnect switch with a lock and tag to prevent unauthorized operation. Lockout/tag-up procedures should be strictly followed to ensure the safety of workers. Fourthly, ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock by detecting ground faults and interrupting the flow of current. GFCIs should be installed in all wet locations, such as bathrooms, kitchens, and outdoor areas, to provide protection against electrical shock hazards. Fifthly, arc flash protection is essential for preventing serious injuries from arc flash events. Arc flashes are explosive releases of energy that can occur when electrical equipment fails or is improperly operated. Arc flash protection measures include conducting arc flash hazard assessments, implementing engineering controls such as arc resistant switchgear, and providing workers with appropriate arc flash PPE. Finally, regular inspections and maintenance are crucial for identifying and addressing potential electrical hazards before they lead to accidents. Inspections should include checking for damaged wiring, loose connections, and overloaded circuits. Maintenance activities may include tightening connections, replacing damaged wiring, and testing safety devices. By implementing these comprehensive electrical safety measures, you can create a safer work environment and protect people and property from electrical hazards.